All right, here comes the proof of the quotient rule. The quotient rule is a tool we use to take the derivative of a function when it is defined as the quotient of two other functions, or in other words, two functions being divided, one function being divided by another. In this case, we have u being divided by v. As we can see up here, that's what we're beginning with. Okay, and then we begin with the definition of derivative of y, dy dx. So limit as x, delta x approaches 0 of y plus delta y. I think my y got erased here. Y plus delta y minus y, which is essentially equal to delta y, but we write it as y plus delta y for a particular reason. And you can see that as we go to the next step. We substitute in the v's and the delta v's. And so we have here u plus delta u minus u. U plus delta u and v plus delta v, right? Essentially, when you plug in x plus delta x, you get out u plus delta u or v plus delta v, and so that's the same, and then you can divide those, u plus delta u divided by v plus delta v, and that's the same as what you get if you plug x plus delta x into y. And therefore, we replace the y plus delta y with u plus delta u divided by v plus delta v. And of course, y gets replaced by u over v. Then what we want to do is take this and modify it and change it around until we can get our final product, the quotient rule down there at the very bottom. So the first thing we do, we want to cancel out these numerators, right? These numerators, with these fractions within fractions, are ugly. So we want to cancel those out. So we're going to multiply by each of those denominators. I think I said numerators before. I meant denominators. We're going to multiply by those denominators, and since in order to multiply those, we have to also divide by them so that we're essentially multiplying by 1 and not changing anything. So we're multiplying by this big fraction. On the top, this new thing that we're multiplying by gets distributed, okay? Because the numerator of our original function is a difference, right? It was a quantity of two things being subtracted, right? So we have to distribute into that. So you see it gets distributed here and here on the top. And then on the bottom, it just kind of slides in. Okay, multiplies by that delta x because it was just a single term. What happens then is over here we can cancel the v plus delta v. And over here we can cancel the v's, right? And then when we clean that up, we get our next step. And I think I'm going to number these steps so that I can talk about them a little easier. Step 1, step 2, step 3. Okay, so step 4 is just what we get when we clean up the canceling from step 3. Then we're going to distribute the v into this quantity and the u into this one, and we get step 5, right? And hopefully you can follow along with the colors, the blue and the reds, and you can see where each of those go. When we do that, the u and the uv terms cancel. And so when we clean that up, we get, this is what's left of that whole numerator. Okay, and what I've done here is I've taken the green, right, the denominator, the green parts of the denominator, and moved it over so I get this whole new fraction. And if you think about it, if you multiply these two fractions together, you get back to step 5. So step 6 is just the separation of the denominator. So I have two separate fractions multiplying by one another. And the reason is because what I have over here on the right is basically the whole quotient rule, with the exception of the v squared on the denominator. I have basically there the numerator of the finished product of our quotient rule. A little rearranging makes that a little easier to see. I distribute the x into both terms here in step 7, and kind of move the u and v terms kind kind of to the side of the fractions. And then what I'm going to do is distribute the limit into all that. I'm going to take the limit of the product. And so kind of take the limit of this fraction and the limit of that fraction. And then furthermore, take the limit of each of these fractions in here. The v is not affected by delta x approaching 0, nor is the u, so they pop out of those limits. And we get, right here, what we have here is the limit as delta x approaches 0 of delta u over delta x, which is, of course, just, oops, that's not working, which is, of course, just du dx. And then, similarly, we have dv dx right here, right? And so that's where we get our u prime and our v prime. And we rearranged a little, put the u afterwards and stuff like that. But it's this over here that may be the trickiest part. We have the limit as delta x approaches 0. Okay, well, 1 doesn't get affected as delta x approaches 0. 1 is just 1, right? Neither do either of these v's. The v's are not affected, and you can see that if you look over here at this graph of the v function. As delta x approaches 0, this line, essentially, it's this x plus delta x location that's moving. Right? It moves over, and those aren't very good-looking arrows. But what happens, you know, all that does is makes that line up there move down. It does not affect v. V sits still. So these v's stick around, but delta v, right? Delta v, which is in here, goes to 0. So that delta v term cancels out. Okay, and all we're left with is the two v's being multiplied, which gives us v squared. And then, obviously, a little rearranging, du dx is just written as u prime, and same with v prime, and we get our final product. I'm going to show an alternate way to prove the quotient rule. That was it right there, and this be step 8 and step 9. And then step 10 is basically just a rearrangement of step 9. I'm going to show a alternate way to prove this quotient rule. If we just say y equals u over v, we can rewrite that as u times v to the negative 1. Right? And now we can just use the product rule, which is u prime v plus v prime u. So y prime is going to be u prime v, which in this case, actually, v is like this whole thing. It's not just v, but v for the product rule becomes this whole quantity. So I have to put v to the negative 1. Okay, plus v prime. And again, we're talking about this whole quantity here. So it's going to be negative 1 v to the negative 2. And I'm going to do the chain rule and multiply by v prime. And then times u to finish out our product rule. Okay. So I'm going to simplify this. V to the negative 1 can be written, so we have u prime over v minus, because there's the negative, and I don't need that 1, so it's going to be v prime u over v squared. To make this into, and this would work, this is sort of an alternate product rule, but to make, alternate quotient rule, but to make it look like our familiar quotient rule, we can multiply this first fraction by v over v, and we get u prime v over v squared. I just added a v to the numerator, multiplied a v times the numerator and denominator, so it doesn't change anything. V prime u over v squared, and then of course we have a common denominator, so I get u prime v minus v prime u over v squared. Okay? And that's the product rule.